Let's take a moment to consider a function. We'll call it f, which is a function of some variable x. Okay, so we'll take a look at it too along the coordinate system. So here's x, here's f of x, and let's let f of x be equal to an exponential function, meaning that it's equal to some base value which is going to be defined, it's going to be given to you, okay, to the x power. So for example, we could say something like this. Let's let f of x be equal to 2 to the x. This is an exponential function, and you know that when we graph this out, if we plug in 0, we get 1 out. Okay, and if we plug in 1, we get 2 out. So these two guys are on the graph, and so this looks something like that. Okay. Now what we want to do is we want to go ahead and find the derivative of this. Okay, so let's go ahead and find f prime. Well, f prime, the derivative, is equal by definition to the limit as delta x goes to 0 of f at x plus delta x minus f at x all over delta x. So let's go ahead and substitute in what we know. Let's just work with a generic function like this. Okay, instead of just 2 to the x, let's work with all bases. Okay, so we're going to let f of x be equal to b to the x, not this guy down here. Okay, because that's just one specific case. I'd like to look at all cases. So f of x is going to be equal to the limit as delta x goes to 0. Now f at x plus delta x is going to be b raised to the x plus delta x, and f at x is just b to the x, and that's over delta x. So f prime of x is the limit as delta x goes to 0 of, now this guy right here we can split into b to the x and b to the delta x. So multiplication between those guys right there, minus b to the x over delta x, just like that. So f prime at x, that's equal to the limit as delta x goes to 0. This is going to be b to the x, we can factor that out, times b to the delta x minus 1 over delta x, just like that. Now b to the x does not depend on delta x. Okay, delta x going to 0 is not, it does not impact this x right here. So we can bring it out. And so we can say f prime of x is equal to b to the x times the limit as delta x goes to 0 of b to the delta x minus 1 over delta x. Well, now what's this guy right here? Well, this guy right here, okay, on the inside, if I rewrite b to the delta x minus 1 over over delta x, and we take the limit of this guy, okay, I'm not going to write that down because it'll get bogged down over here, but this is the same as b to the 0 plus delta x minus b to the 0 over delta x. Remember, that's just this inside piece right here. It's just this guy that I'm working with over here. Now this right here is really, if I take the limit of this, f prime at 0 is equal to the limits as delta x goes to 0 of b to the 0 plus delta x minus b to the 0 over delta x. But this is exactly what this is right here. So these two guys are equal. So in general, f prime at x, not just at 0, is equal to b to the x times the derivative at 0, assuming that the derivative exists. And it does. Okay, this exponential function is continuous, okay, in this area, and more importantly, it is differentiable. Okay, it's not, doesn't have any cusps or any points or anything like that. Okay, so it is differentiable at 0. So what we've found now is a generic way to find the derivative of b to the x. So d dx of the function b to the x is equal to b to the x times the derivative of the function, okay, evaluated at 0. So we'd have to know this guy, and we'll discuss how we get that value here.